So my subject is drug discovery using neural network. As a very brief description, a protein is a macromolecule that functions in our body, and bacteria or virus can invade our cell to make their own protein. And basically, every single protein has very specific binding site where a small molecule can bind if they have a compatible 3D structure to the binding site. So the point of drug discovery is to find um, small molecules that can also bind to the target protein binding site, so that the binding site is blocked and the protein from virus or bacteria can be inhibited. So drug discovery is a very expensive task, and there are infinite numbers of chemical that can be composed in a lab. And obviously, it is impossible to test all of the existing chemical compounds. Actually, there are several software that you can use to screen candidate drugs out of a lot of small molecules. But these were not very practical because, first of all, you have to give very specific directions, and from this, there are a lot of uncertainties that you cannot expect. So the most of the uncertainty comes from the fact that there are infinite numbers of combinations of the fragments, and the infinite number means that we cannot perfectly predict what kind of effects the small molecules that we found will have in our cell. For example, as I said, we design a drug to target a specific protein, but it may turn out that the candidate drug that we found can also bind to another protein that we didn't expect, and this may cause very serious side effects. And also, there can be incorrect information in the experimental data set that we use to build a drug discovery model. Another uncertainty is that actually a lot of viruses are very good at mutating themselves to find a way to resist to a new drug. So for this reason, neural network has been adopted to the application of drug design. Um, there are a huge number of experimental data, and we can use them as training set. So basically, uh, the reported molecules from each studies are characterized into a binary code, where each bit in the binary code represents the small fragments of the molecule. And this binary code is provided to the neural network. And this approach has shown a huge potential as the future drug discovery model. And since 2009, a lot of reports came out showing that this approach could predict the activity in the cell very well. But still, most of the studies so far have focused on single target protein. And as I said, there is the uncertainty of um, the side effect from other proteins, also the mutational effect. So, and drug design team in Stanford and Google collaborated to improve the neural network so that it can utilize uh, utilize the different experimental data from different sources with different target proteins. And this way, uh, they show that it really improves the accuracy, and also it avoids the risk of the side effect. And also, they also use the cross validation that we have seen in our class. So this is all. And if you are curious about this approach more, you can check out the references that I attached. Thank you.